All right, well, I'm going to get started. So hi, everyone. I am Katie from Hackster, and welcome to Powering the Next Generation Low-Power Computer Vision Applications webinar with Edge Impulse and Arduino. Today we have Xin Cha and Andrea Riquetta here with us to share more about how you can use Edge Impulse to deploy low-power computer vision applications using the Arduino Portenta H7. So just a little bit more about our speakers today. Xin is a senior user success engineer with Edge Impulse. He has over 20 years of experience in embedded systems and IoT design and development. He's worked with startups and multinational corporations, and he's currently working with Edge Impulse's ecosystem of developers, partners, and customers to solve real-world problems. We've also got Andrea, the head of Pro Business Unit at Arduino, and he's responsible for providing solutions and companies that want to integrate and leverage the various Arduino solutions into their businesses. He's worked at Arduino since 2014, and prior to his current role, he was a product manager responsible for manufacturing. Before joining Arduino, he served as ICT telco manager in a multinational company within the events industry. So thanks both Xin and Andrea for joining us today. The first 45 minutes of today's webinar is going to include a presentation and a demo, and the last 15 minutes will be open for your questions. So if you do have questions during the webinar, there is a Q&A at the very bottom of your screen. You can click on that and type your question in there, and we'll try to get to as many of those as possible. So Xin and Andrea will answer those at the end of the webinar. And then as part of this webinar, Edge Impulse is giving away Arduino hardware bundles to 10 lucky winners who attend the presentation and demo live with us today. So the bundle that includes the Arduino Portenta H7 and an Arduino Portenta Vision Shield. So winners will receive an email later next week with more information on how to claim that prize. And thanks again for joining us. I'm going to let Andrea get us started.
Okay, thank you, Kate. Thanks for the introduction. Hello, everybody. Thanks for joining us today. My name is Andrea Riquetta. I'm head of the Pro Business Unit. Today, I would like to introduce a little bit more on the Arduino and the Arduino Pro products that you will see during the demo from Xin. So starting from the introduction, our mission is to enable anyone to innovate by making complex technologies simple and open to use. So this is the mantra, and so this is the mission that we have since the beginning. Our office is, just to give a glimpse on where we are. We have an headquarters in Switzerland, all the R&D and sales are in Italy. Then we have the education in Sweden, and then we have a sales office in the US and APAC in Australia. We are now organized into 3 business units with the idea of combining different kind of knowledge and provide a complete journey. So starting from the Arduino Education Business Unit, where it's supposed to start learning by doing, then moving forward to the Arduino standard, the historical one, where you can innovate and find creative solutions for everyday challenges. And then that's the shift to the Arduino Pro, that the main mission is to enable business transformation. So regarding manufacturing, probably you're curious about that. All the products that we provide are manufactured in Italy. We have different OEMs with a lot of SMT lines. So we want to ensure high quality standards and a dedicated line for the Pro products. The strategy here for the Pro business unit is to provide a complete journey to customers, start from learning to prototyping and going to production. So today we will talk about two pieces, two hardware. One is the Portenta H7 and the other is the Vision Shield. On the technical side, the Portenta H7 is the latest product that we have in our portfolio, and it's based on ARM embedded operating system, and it has a dual-core microcontroller, the M7 and M4. We have a radio module that provides Wi-Fi and Bluetooth. We have secure element, actually 2 secure elements, because for us, the security is of paramount importance. And we have a really low power consumption that starts at 2.95 microamps in standby mode. And then we have temperature range, we have ADC, DAC, and then we have different kind of connectors. One for the MKR family, and we do have also two high density connectors that provide 160 pins out of the board, where you can leverage and you can scale up with the projects. Use cases for the Portenta H7 are mainly thought when you need power, when performance is the key. So you can use Portenta H7 high-end industrial machinery, computer vision, industry user interface, robotics controllers. There's a lot of projects out there, and mission critical devices. Then we partnered with the Edge Impulse to unleash the power and the capabilities of the AI and the machine learning. So starting from the great Edge Impulse Studio, you can create all the things and provide the model trained and on the board. But I don't want to spoil it because Zane will provide him a great demo. And then we also partner with OpenMV to have a fully functional out-of-the-box IDE that supports MicroPython. So again, you will see how it works. Then on the Vision Shield, this is the other part of the demo of today. The Vision Shield is equipped with a camera sensor as a IMAX QVGAs, support QVGAs at 60 frames per second. It's a low power consumption, starting from 670 microwatts. It has an Ethernet connector and two microphones. So completes the equipment, a JTAG connector that can be used for debugging purposes, and an SD card. The board, the shield is also available with LoRa connectivity. So you can use or the Ethernet connector or the LoRa network connectivity. This for regarding the use cases, basically by leveraging on the camera and the audio, you can have applications like AOI, so automatic optical inspection, people object detection, recognize people in different situations, anomalies detections, either audio based on the audio and on the video, and beamforming applications. So leveraging the two microphones that we have on the board, on the shield, you can improve, for example, the signal to noise ratio and create a very precise environment for the audio. So that's it. I don't want to, steal a lot of time because the demo will be really, really interesting. So thanks. See you during the Q&A session. Don't forget to write the question in the box in the Q&A section. And now I leave the stage to Zane. Thank you.
Thank you, Andrea, and thank you, Katie, and also thank you, everyone, for joining us this morning or this evening, wherever you might be. Let me share my screen. So we're really excited that you guys are here. We're going to be talking about powering the next generation of low-power computer vision apps. So today's agenda, we're going to just give a quick background on the current state of computer vision and what's next. We'll provide a walkthrough and introduction into Edge Impulse, talk a little bit about our collaboration with Arduino, and then that'll conclude the sort of slideware piece, and then we'll go into the demo, and then we'll finish off with a Q&A session, and we'll try to answer as many questions as time permits. So let's take a quick state of the computer vision union, as I would say, that exists today. So typically when you think of computer vision, it means expensive camera systems or mobile phones, as you can see on the right-hand side, not typically power efficient, requiring wired mains power, and not able to run on battery power. Also, very high cost to install. So to actually get people to install these wired cameras, there's definitely a pretty high labor charge with that, up to $400 to install an actual camera device and configure it, whether that's through Ethernet or something like that. And that does not include the wiring cost itself. So that's also an extra cost, right? To actually pull the wire to the camera. And so it ends up being a pretty costly cost of ownership if we look at deploying multiple cameras for any kind of installation. So how nice would it be to actually just plop down a very low cost wireless battery powered camera everywhere you need computer vision? I think we're heading towards that era now. And of course, in terms of AI and machine learning for computer vision, the current state of the market is also where you have a lot of complex and what we call disparate tools for implementation. So if you were to actually draw a picture of the tools that you would need to do machine learning on computer vision, it would literally look like a fridge where you put like post-it notes. You have like a script here, another piece of tool here, another tool here, another script. So it starts looking like a wall of post-it notes pretty soon. And this is where Edge Impulse can help. So as I mentioned, computer vision is moving to low power, low cost, and sensor fusion. So we can address the challenges that we saw in the previous slide by leveraging embedded machine learning and edge sensors powered by the Arduino Portenta H7 and with the Vision Shield. So these days we're seeing tighter and tighter integration on MCUs with more and more features. So we're really closing the gap with traditional computer vision devices that use processors running embedded Linux that are typically higher cost and consume more power. And of course, the Arduino Portenta H7 has an dual core architecture comprising of a Cortex M7 and Cortex M4. So we're seeing more and more capabilities in devices such as the Portenta H7 that are fully capable of low power computer vision for a fraction of the cost and power consumption. And then of course, for example, you could potentially run your sensor fusion model on the Cortex M4 and your computer vision model on the Cortex M7, and then do things like save power by only activating your computer vision model when your environment provides the necessary trigger through sensor fusion. So we can start doing a lot of these cool things like that, combining embedded machine learning, AI, IoT, and the recent advancements in MCUs like you see here. So as I talked about sensor fusion, the Portenta H7 is a complete system on chip, right? Or system on board. And so not only can we do computer vision, but we can take sensor input and then train on that data in order to provide the necessary triggers. So for example, I can also detect, hey, is my temperature getting close to hitting a critical threshold? Are there vibration patterns that will lead to a fault state in a week? Is my average humidity outside the safe zone? So we can start combining sensor inputs, combining that with audio, combining that with vision, and really making something, creating applications that never were possible before. And so, as engineers, we can use a data-driven approach now by using machine learning to model those behaviors and signatures in the environments that we care about in the field, run inferencing at the edge, and then in terms of IoT, only then send the conclusions to the cloud. So in the past, we used to basically send everything to the cloud, like all the measurements, and have the cloud do the number crunching. But now we can actually do the number crunching closer to the edge, at the edge device, so that we can save on bandwidth, energy, and also operational costs, because the less data we can send to the cloud, then obviously the cost of ownership gets lowered as well. So this is where Edge Impulse comes in. We are the leading embedded ML development platform. And, really, when people think of machine learning, I think most people might think of it as kind of this magic wand or silver bullet. But really, we're looking at embedded machine learning as another tool in your toolkit as an embedded engineer. You guys are so used to all the tools that are available for realizing IoT applications. And then now here comes embedded machine learning to give you another arrow in your quiver, if you will, to help solve the problems that are out there that you're trying to solve. So, what we're doing is providing you a complete one-stop shop with an awesome end-to-end user experience, so you can quickly deploy your embedded machine learning solution. It is, after all about time to market. So the less time that you have to spend doing a POC demo, which then leads to actually production ready code, the faster you can get to market. And obviously that gives you the ultimate competitive edge. So as I mentioned before, we're giving you this end-to-end experience where you don't have to worry about, oh, I need this framework over here, I need the script over here, I need this other framework. Like, it's all inclusive, one-stop shop where you can acquire your data, train, and then obviously deploy that to embedded devices like the Portenta H7 in a very easy to use manner. So you can use our Edge Impulse Studio to manage your entire embedded machine learning pipeline. So as I mentioned, easily and securely acquire data directly from your devices for your training data sets, design, train, and validate your embedded ML model, what we call impulse design, using our built-in signal processing and learning blocks. And then finally deploy optimized embedded code at the edge, as you can see by some of the flash and RAM statistics we show on the right here. This is a sample of the instant analysis you can get on how your model is performing within our Edge Impulse Studio and what kind of resources will be utilized on your embedded device. Of course, at the core of making embedded machine learning work for you, just like anything else, is making sure your data sets are robust. So we've made it easy and secure for you to be able to import your data sets into our studio. There's a myriad of ways of getting data into the system, training data into the system. You can use our built-in command line interface tools, your mobile phone, or even your PC. Of course, upload any existing data sets that you might have within your own bit buckets from various available cloud services like AWS, Azure, or GCP. So we're also enabling enterprise collaboration with what we're calling embedded ML ops. And ML ops is actually an actual discipline these days. And at Edge Impulse, we are answering the bell in terms of how, as an enterprise, you can have a seamless workflow that allows your teams to manage your embedded ML projects. So we're talking about larger teams, comprising of engineers, data scientists, developers. And so for device makers in the enterprise environment, we offer you all of those collaboration tools necessary for seamlessly collaborating with other individuals from your organization across teams and to perform iterative development for enhancing the performance of your embedded ML model. Realizing that machine learning is not just a one and done approach. You're constantly revising how well your model performs, collecting new data. And so there's this feedback loop that's always in this one continual stream. And you want to be able to effectively manage from inception to deployment and keep being able to do that in a seamless manner. For example, being able to save your project work so that you don't lose the performance you had from before is an example of one of the things you can do with our platform. So let's talk about now shift to some of the case studies that we're seeing that could certainly be powered by something like the Portenta H7, of course. And just to give you a good idea of where we're seeing advances in embedded ML. So the first one is making health smarter with ML. We partnered with a leading wearable health device maker to accelerate the research and development of new sleep and flu onset detection algorithms. Our enterprise features actually empowered them to set up this full embedded ML ops pipeline that I just talked about. This really allowed them to perform iterative embedded ML development through cross-functional collaboration and really just save them man years in terms of effort for deploying these new embedded ML algorithms. And that's really speaks to the sort of seamless pipeline that we've helped them establish versus the previous techniques, which is to use a collection of disparate tools that I'd mentioned before. Next up, we have making the grid smarter with ML. So we collaborated on a solution that enables remote monitoring of power grids and devices called surge arresters. Surge arresters are devices that protect electrical equipment from overvoltage transients caused by external events such as lightning or internal voltage switching events. Embedded machine learning with edge impulse provided the ability for the system to gain insights by way of the different sensors on this RAM1 device that you see here. And through anomaly detection, embedded ML algorithms, the system was able to only send the insightful conclusions to the cloud, thereby enabling the device to achieve a very long battery life, 10, 20 years of battery lifespan in the field. Last but not least is making wildlife conservation smarter with ML. So the Elephant Edge initiative inspired a plethora of projects to help elephant conservation and fund the development of the next generation elephant collar, which would see, of course, the fusion of IoT and embedded ML at the heart of those innovations. Edge Impulse provided the embedded ML platform to leverage sensor data from the devices, such as the elephant collar, allowing researchers to understand more about how elephants behave in their natural habitats and respond to external threats like poachers, for example. Elephant Edge is, of course, only one example of wildlife conservation, as there are many animal species in the world that are endangered today where embedded machine learning could help. Now let's talk about our collaboration with Arduino. So on the Portenta H7, we have developed fully supported standalone inferencing example projects that run on the Portenta H7 and leverage the Vision Shield with the LoRaWAN connectivity. So we in the additional resources section slide, we'll actually provide links to where you can download those preview examples and tutorials. You can, of course, train your models in the Edge Impulse Studio, as you can see in the screenshot here, and then build downloadable binary images to run on the Portenta H7, which supports a drag and drop interface. So the device shows up as a drive, like a USB drive on your system. So it's as easy as just dragging and dropping that downloadable image on there and you're off and running. So we'll talk a little bit about the demo, and I have a couple more few slides, and then we'll actually do the demo itself and show you that. So for this webinar, we developed a Price is Right demo using digits detection. So digits detection is one of those things that's actually quite well known in the field of ML. And so we've been able to implement that quite seamlessly, combining both Edge Impulse and Portenta H7 here. And so we ended up with a 96 by 96 grayscale model. We use the OpenMV IDE to actually develop and run the code. And of course, we can achieve real-time low-power inferencing with the help of Portenta H7 hardware. So we'll see this in a little bit. I just have a couple more slides. So some of the application areas for this is only one vector in low power computer vision, digits detection, but this has potential autonomous applications in grocery retail, for example. So instead of sending a human being to handle a price label mismatch, you could, for example, send a drone, in store with this kind of tech. Things like use by date inspection could be applicable here. For manufacturing, definitely product line inspection, quality control monitoring. In the smart metering space, meter reading of smart meters and legacy meters, for example, that obviously are displaying digits on them. And then in some cases, in the administrative field, you could even do license plate detection. This could, of course, be extended to alphabets as well. And in some countries, like Japan and Korea, the license plates are actually all digits. And of course, potentially also in handwriting recognition. So how to get started with Edge Impulse and Arduino Portenta H7. So sign up for free at edgeimpulse.com. It's free to use for developers and also free to deploy if you have projects that you want to get this into. And some great starting tutorials and example projects for you. So we have a pretty good tutorial for adding sight to your sensor. So if you want to get started with image classification, this is the best entry point. You can even use your mobile phone, for example. And then, of course, the plethora of Arduino Pro tutorials, please go there, because there are several tutorials on how to use different features within OpenMV, like blob detection, for example, that can be very handy. And here's a slide on the additional resources that I mentioned. So one is, of course, this great Coursera class that we launched recently. So if you're new to embedded machine learning, or just machine learning in general, or even embedded in general, this is a great place to start learning. And you could also get your certificate. I think it's like, it's free, but if you want to get the certificate, it's like $49, not too much. So if you want to share that on your LinkedIn or whatnot, that's a good reason to get that. And then, of course, we have these preview example and tutorial, which which basically uses a firmware that we've developed that runs on the Portenta H7. So you can take a look at that. This is a preview release. So I think probably in the next little while, we'll target making an official release. But it's fully functional, and you're definitely welcome to try it. And definitely give us feedback on our forums. You know, if you like it, you know, you see something that could work better, so we could incorporate that into the final release. But that is coming soon, probably in the next month or so, maybe towards the end of April, if everything goes well. But for now, you can try this out and give us your feedback. So recently, we've seen quite a bit of uptake in terms of interest, as well as the number of developers and projects. So these are actually the latest stats we have today. Over 9,500 developers, over 15,000 projects in our studio, and which results in a greater than 12 million of dataset samples. So our DNA is basically an embedded. A lot of us come from ARM. And so, you know, we've assembled a team of industry leaders and embedded experts. And our hope is that it will give you the best developer experience for embedded ML. So we have embedded ML being deployed everywhere and at scale. So definitely come check us out, try us out, and let us know what you think. So what I would actually like to do is actually walk you through our studio a little bit. But this is actually how I constructed the design of this model itself. So the first step is actually, of course, to import all of your training data. So the way that you can do this is many faceted. So you could you even use your mobile phone, your computer. But in this case, for example, I ended up using the famous Character 74K dataset as a baseline, which is openly available out there. And I uploaded all of that. And what I did too was I augmented that data set with numbers from license plates, as well as shopping labels, pricing labels, and that formed the basis of my data set. But as you can see here, we have a number of various ways of doing that. And of course, if we also have the client running on the device, we can directly stream that data into Edge Impulse as well. And of course, do that securely. So once I get that into my system, the next step is to do the impulse design. And for this, as I mentioned, I use a 96 by 96 grayscale model. And this screen allows you to add different signal processing blocks and different learning blocks. So, you know, obviously for computer vision, it's just image processing. But for other sensor data and audio, we've got different DSP blocks for that. And the point of adding these DSP blocks after the data is to prepare the model for training on it by using feature extraction. So you want to try to get unique signatures out of the data that you can give your model to train on. And you know, for image recognition, we use transfer learning. So later on, you'll see that we use a MobileNet V2 transfer learning model. But of course, if you wanted to create your own model, you could definitely use a Keras block and then create your own layers there if you want to create your own model. So that's definitely an option for you if you didn't want to use MobileNet V2, for example. And then once you've done that, you're going to save your impulse and then go to the next step. Which for image recognition, basically there's only one parameter we have right now, which is it RGB or grayscale? And since our sensor is grayscale, we're going to specify grayscale. And then we're going to go to the feature generation tab, which is going to give you this nice 3D visualization printout here. And so you can see the color coding being all of the different digits, 0 to 9. And you can see that there is, pretty clear separation in terms of the features of each digit, which is great because this likely means that our model training is going to be successful and that we're going to get good results. So this is kind of what you want to look for, is this kind of separation in your data after you've extracted the features. And then the last part is the transfer learning. So this is where you can specify, the different kind of MobileNet V2 transfer learning models. So we have 3 different ones. Depending on the size of your device, your embedded device, you can try to experiment with maybe using a lower version, which will further optimize the amount of flash and RAM that's being used. But in this case, the H7 supports quite a bit of flash and RAM. So we're optimizing for more accuracy than we are for actual code size. So this is why I've selected MobileNet V2 0.35. And, you can also, of course, if you declared a block in Keras and you want to go into expert mode, you can actually edit in Python as well. So in case you're a pro user of Keras and you want to do that and you're more comfortable with that, feel free to do that. But I think for most people that are starting, they will obviously start with the visual mode. And once you hit start training, this will take a minute. And then at the end of it, you'll see this performance statistics on the model as well as confusion matrix. And this is an estimate of how well the model is going to be able to differentiate between each of the labels that you've presented it. So in this case, I've got 10 labels, 0 through 9, and you can see that my accuracy is going to be fairly decent. And then, of course, you also get the same 3D visualization model you can see, and then the statistics for how much RAM, ROM, and how long the inferencing actually takes for this application. So that's how you could basically specify what kind of model you would want to use. And then, of course, we've got a bunch of other tools here. So in terms of model testing, once you've uploaded your test data, for example, in this case, I've uploaded some samples of different numbers and images, so I can actually batch classify them and just run this, for example, and it'll output all, basically allow me to test how well my model is doing. You can also save your project in terms of, remember I said, if you want to save your project and go back and let's say you did something and it messed up your model, it's great to have that work saved. So this is where you can create, store your different project versions depending on how you modify the settings for the different models. And actually, you can even create different blocks for a transfer learning model. So we created this feature called block versioning, which allows you to have different versions of your transfer learning block. And so this allows you to tweak different settings in here. For example, if I wanted to see how well the model performs, if I bump this number to 20 training cycles, I could actually clone this as a new version so that I don't save those previous settings. I don't lose those previous settings from before. So that way, each iteration of my model development is saved, and I can basically switch back and forth and see which one I want to actually deploy and test. So a very flexible way of doing experimentation without losing your work. And of course, the last part is a deployment. So for vision, we have a number of targets here that will produce this binary file that I mentioned before. So in this case, I had selected OpenMV, and it'll produce a model that I can drag and drop onto the, and a set of labels that I can drag and drop onto the Portenta H7. And in general, when we talk about sensor fusion and these kind of things, you can export to an Arduino library, of course, and also a C++ library, which has no third-party dependency. So this makes it really easy for you to deploy your embedded machine learning model and then integrate that into your development environment. So it doesn't require any complicated steps. And literally, when you include your model as a C++ library or Arduino library, it's like one line of code to include that library. In the case of Arduino, is of course adding the zip file as a library. And then for the actual inferencing piece, it's literally like 5 lines of code, and you'll be able to see that in the standalone example that we mentioned before. And now we will switch to the demo itself. So what I've done here is you can see the OpenMV IDE here, and I just have a price label that I've picked up from the web. And for my testing purposes, and this field, if I can zoom in, yeah, okay, zoom in, I think. Try to make it a little bit bigger if possible. Oh, okay, all right. So you know, a lot of this is also application design. So I try to do this without any external hardware so that it's easy for people to try it out. And so what you'll see here is basically the price. When I turn this on, you'll see the price at the bottom. And I had to kind of, you know, come up with a clever way to basically trap each digit as I go through the scan. So what I'm doing here is basically pointing the camera at each digit and then moving along from left to right so that at the end, I get the total price number at the end. So when the camera moves across, you'll see the actual digit being recognized at the top left-hand corner. And then this number over here is basically like my timer. So when it goes past a certain count, it's going to move to the next digit. So I basically have like an array that tells you what digit it is, and I pump that into the array, and then eventually you get that you get the price at the end. So that's what this number is. So you'll see the price over here, and then the total price hopefully at the bottom once I finish scanning through all 3 digits. So let's try that out. So I got the first digit. Move on to the next one. And then the last digit. There you go. So I got 4068 as the price. And there it is. So as I mentioned before, you know, there can be a lot of different applications, as I mentioned, whether it's an administrative or maybe it's smart meter reading, and a lot of different other applications where this could be applied to. And, you know, a lot of people are using like drones to do some of this autonomous stuff. So, you know, imagine a drone being able to actually go into this, being summoned in the store, right? And actually, instead of sending a person to go check a price label mismatch, you could actually summon a drone to do that for you. And that's exactly what it would do, is basically go left to right and scan across a label and, you know, definitely improve operations that way. So that about concludes it for the demo and the slideware part of the presentation. And I think we actually probably have some time here to take some Q&A now, Katie.
Great. Awesome. Well, thank you for that. Yeah, we have quite a few questions coming in. So just a reminder to people, if you do have questions, there's a little Q&A icon at the bottom of your screen. So you can click on that and type your question in there. So that's how we make sure that Zin and Andrea will see them. I know I saw some questions coming in through the chat, which is super exciting too, but just make sure you put them in the Q&A. That way they don't get lost in the chat and we can make sure we get to those. So I'm going to let Andrea and Zin kind of go through these and answer them, decide who's going to be the best person to answer each one. I know that there's some for each of them in there. So thanks so much, guys.
Yeah. Well, there's Timothy that is asking for the LoRa-based shield. What gateway I can use? Can I transmit image over data, over LoRa? Basically, the shield is compatible with any kind of gateway in different regions, and so you can. The answer is you can use whatever gateway you want. We have actually a good demo from Jon from Edge Impulse that we realized that we did for the Things Network conference. So you can probably check it out. It's available on YouTube. And so you can see the usage. Of course, no, you cannot send image data over LoRa because LoRa is low low power and long range protocol, so it's not used as to convey a lot of a lot of payload, big payload. But you can see that in that case is used for transmitting the results of the inference. So you can do the local image recognition and then send the result of the recognition as it was for the demo that Zin did. So a typical example is that instead of providing and send the image, you can provide and send the price, so the result of the inference. Then I can reply to Jay that is asking, I'm a freelance electronics and I would like to become a certified Arduino Pro engineer. There's something that will be released during next month, and it's about system integrators. So I suggest you to subscribe to our newsletter, and so you will be notified when we will be live. Okay, so I can pick up this one from Ralph Yamamoto. Is the LoRa version of the Vision Shield capable of running inferencing without using the Portenta? Does Edge Impulse support this? Well, basically, the answer is that the LoRa Vision Shield is not capable. It doesn't have a microcontroller, so basically, it can be used attached to the Portenta. So the inference model is generated by Studio, Edge Impulse Studio, and then downloaded to the Portenta. So it's just a shield that adds vision and audio capabilities. There's a random question here. Can we deploy two machine learning inferences individually on the M7 and the M4 core on the Portenta? Probably it's a mixed question, but what happens is that, again, you can run all your inference and, do your stuff into the Edge Impulse Studio, and then you get, as a result, the model that you can upload to the board. While uploading, you can choose which core you want to upload to. So you can use the Portenta, the M7 or the M4. Of course, it really depends on the model or the train or the data set and all the model itself, the trained model, because remember that the M7 has a huge computational power, while the M4 can be used, but with different purposes. I don't want, Zin, if you want to add something on this.
Yeah, you summarized it pretty well, and definitely, as we highlighted on the outset of the presentation, that's definitely a really intriguing way of application design. Combining sensor fusion, so running that piece on the M4, and then the the computer vision model on the M7 is going to be, I think, a really powerful combination. And then, of course, there's also like a ability to talk between the two cores, I believe, right, Andrea? Like some kind of RPC. So imagine utilizing that to facilitate this kind of application design.
Yes, exactly. There's an RPC that is used for communicating between the two cores. So I probably there's a question from Jay Moreale. Is Portenta H7 sketch development occur on the Arduino IDE and the machine learning part developed on Edge Impulse or is done all on Edge Impulse? What is the tool chain? We have different tool chains. We have two tool chains, basically, one on the Edge Impulse and one on the ID. Basically, the tool chain from Edge Impulse generate the model, and then the tool chain from Arduino IDE that is based on the CLI, so the command line interface, is the tool chain that is used to physically upload the model to the board.
Yeah, and to expand upon that, basically there are two paths of development. So you can kind of go the OpenMV IDE path. So that's actually one set of firmware. All you need to do is actually just download the model, drag and drop the model to the Portenta H7, right? The other part, which I just put two links into the panel, the chat. But basically, we've got preview example and tutorial where you use the Arduino toolchain, and then you can write standalone firmware, inferencing firmware that loads onto the Portenta H7. So you guys can go check that out. As I mentioned, it is preview. So give us your feedback on that, and we'll try to iterate on that. But I would expect probably an official release towards the end of April for that. I'll take one from, I'm not sure how to pronounce his first name, Thies, maybe, from Tata Steel. He says, I am wondering about the maintainability of such embedded computer vision models in a manufacturing industry. Can models be maintained centrally? Yes, certainly. As I mentioned before, Edge Impulse is providing a sort of platform for continuous development of not just vision models, but just machine learning embedded machine learning models in general. So definitely we've designed it from upfront so that you can do this kind of ML ops type stuff and make sure that your models are being, in essence, centrally maintained. So if you have large teams where there's lots of hands in terms of developing a project, we certainly have an enterprise relationship that we could form with you, which gives you more tools and flexibility beyond the free version, for example.
Okay, I get this one from Sergey. What programming languages is supported? If we're talking about the Portenta H7, right now we of course support the standard Arduino language, and we provide also the support for MicroPython. We will have also a JavaScript that is actually doable via an interpreter, but officially we support those two languages. Then I pick the next one. It's availability and cost. It depends on on the Edge Impulse or the Arduino one, but on the Arduino side, the product is available both for the Arduino H7 and the Vision Shield, and the cost is around $100 for the H7 and something like $40 for the Vision Shield. Okay, I pick the next one also. Can you attach a LiPo battery to the Portenta H7? Yes, absolutely. We can attach, and there's a charger on the board itself.
Yeah, and then Kevin asked, do you have any applications for agriculture? So before joining Edge Impulse, I came from Kroger, so we're doing, looking at some things on smart agriculture, and certainly, vision is quite an interesting thing that could be applied there, as well as sensor fusion. So being able to sense things like temperature and humidity, as well as ambient light, this generally informs us on produce yield. So perhaps you could use that for the sensor fusion part. And then I'm thinking that, the vision would be interesting for analyzing crops, as well as also maybe like for pests. So, you could put like maybe poles out there, out in the fields, and, see if there are, be able to detect pests and these kind of things. So certainly. And I think in terms of embedded machine learning with all this stuff, the sky's the limit, really. You are only limited by your imagination. And so we're really interested to really see what you guys come up with, with the combined Edge Impulse and Portenta H7. And we'd love to hear some of your inventions. Tell us about it for sure.
Okay, I get this one from Ricardo Zambon. How does the inferred price be sent through LoRa Shield? Maybe using serial or specific Shield libraries. We have a ready-to-use a library, and for the demo, the library itself is directly supported through OpenMV. So we have either standard Arduino libraries and the OpenMV libraries.
Yeah, somebody also said, can you give me some more details of the tool chain of getting sensor data out of the Arduino IDE into Edge Impulse and back to the Edge device? Is this possible with every controller featuring Arduino IDE in case it's powerful enough? Yeah, I mean, the H7 is, I would say, on the higher end of the MCU in terms of MCU line, in terms of performance and capabilities. But check out some of the other examples and tutorials we have on Edge Impulse. For example, with the Arduino Nano 33 BLE Sense, which is actually part of that Coursera class that I had mentioned. So if you're interested in getting your feet wet, I would recommend taking the Coursera class. And then at the same time, you'll get a great understanding of how to use the Arduino toolchain and that Nano 33 BLE Sense board to do exactly what you just mentioned, which is gathering sensor data and building embedded machine models around that. And then once you're comfortable with that, you can migrate that work to the Arduino Portenta H7. So basically all of that work is reusable. And then of course you could add computer vision by leveraging the M7 core on the Portenta H7. So yeah, it's definitely exciting to see like this ecosystem of tools basically working across different devices. Definitely a worthwhile investment if you're going to invest in any piece of technology.
I take this one from Hessel. Is face recognition possible? Are there samples available? I think that we have a tutorial available on our website that
Yeah, you're right.
identify the face and change it with the image. So yes, absolutely, yes, this is possible.
Okay, I can take one from John Sene. So he says, do you have a cross compiler where you can take TensorFlow Lite to Edge Impulse AI ML? Yeah, in fact, we leverage the TensorFlow Lite framework, under the hood, but we also add on top of that our own optimizations. So actually, we have this compiler called Eon, which essentially compiles the machine learning model straight to embedded C++ code. So, we're not carrying the overhead of the TensorFlow Lite interpreter in that sense. And what we've seen is that by doing this, we can get about 25 to 55% reduction in code size and RAM utilization. And of course, we also provide our own DSP blocks as well, and our own anomaly detection blocks for machine learning. And so we've added on top of TensorFlow Micro some of these areas where we can optimize.
Wow, a lot of questions.
This is great. I love
Yeah.
seeing this engagement. Oh, this is an interesting one. Constantino says, we are interested to use computer vision for fill ratio recognition of water reservoirs via drones. That means that not only the fill ratio will be required to be evaluated, but also the reservoir ID. Would that be an appropriate application for Edge Impulse? Constantinos, I think you just saw the demo of your application. To be honest with you, that's exactly what I had mentioned, which is this would be I think using this kind of digits detection and computer vision with drones is certainly an area where you can basically automate this. So imagine, the reservoir ID being digits based, so you could have the application scan that, and then of course also detect the fill level. So I think this could be a great springboard for you, using the H7 and Edge Impulse.
I pick this one. Faisal, is there a memory buffer to avoid data loss in case of network downtime? The Shield has its own SD card slot, so you can think about to create this buffer into the SD card, and then check if the network is operative, and you can send and then delete the. So you have multiple way to handle this. So yes, absolutely, it's possible. Oh
Yeah. Oh, yeah, go ahead, Andre.
no, there's a nice question. Rahi ask Jetson Nano or Portenta, which one is the best? Well, I can say Portenta, but it's just a joke. But yeah, there are different products, so it really depends on the use case. What I can say is that the Portenta is really fast, one of the fastest microcontroller in the market. So with this dual core capabilities, it's really fast. So I think that it's really difficult, staying on the microcontroller side to have, different or difficult task to be done from the microcontroller point of view.
Yeah, and don't forget, we focus today on computer vision because I think it's definitely a very exciting new field when you talk about machine learning and getting these capabilities down to sort of the microcontroller type space. But keep in mind that as an MCU, you have access to all the other sensors, right? Audio, if you want to do like temperature, humidity sensing, accelerometer stuff, all of that is already available to you, like it is in smaller MCUs, like what's on the Arduino BLE Nano 33 cents. I keep getting that wrong, the order. But, so it is, think of it as a sort of path towards graduating to a more powerful MCU like the H7. And then we also have a lot of questions on, okay, can I run Edge Impulse on this device or that device? And the bottom line here is that, remember when I showed you that deployment page, you basically have two options, really. One is export your model as a C++ library, and the other one is, of course, also an Arduino library. So if you can basically, bring that into any device that you see fit, really. So we offer a Edge Impulse SDK that allows you to include that, as well as run inferencing locally on your device of choice, let's say. And we've got many examples on different devices where we give you a standalone inferencing example. You could take that as a starting point and then write that for your own hardware. Even if it's not officially supported by Edge Impulse, this is exactly what you can do. For example, we've certainly done this with like the ESP32, for example, right? Or other devices. And so these two tools allow you to integrate that with whatever devices you want. And then we have this command line tool called the data forwarder, which basically allows you to collect data over serial UART connection. So that makes it easy to get data into Edge Impulse.
We've got about 1 more minute. So if we want to answer like one more question.
Well, I can keep.
I know there's a lot to choose from.
Yeah, it's really difficult. So thanks a lot. Really a lot of questions. Probably I can pick this one from Carlos Merola. Hi, Carlos. Any release date for end-to-end support for both Portenta H7 firmware and the OpenMV firmware? Well, yes. As of now, we have this for the Edge Impulse. As Zane said, we are close to release the end-to-end support from the Edge Impulse. And regarding OpenMV is already available there because you can, as seen, show there's the library already available on the OpenMV.
Awesome. Well, thank you both so much for today. There were so many great questions, and I'm very, very sorry that we weren't able to get to them all, but I did post the links to the forums on the chat section there. So if you didn't get your question answered, I would encourage you to go over there and ask your questions there and see if there's some other interesting things going on at those sites, because I'm sure you can find a lot of really good information. So I just appreciate both of you being here, and thanks again. I hope everyone has a great rest of your day.
Thank you, everyone. Appreciate you.
Thank you, everyone.
Thanks. Bye.
Bye.